Welcome back to the next episode. This is the third episode in our series. In this episode we will be covering camera movement and object transformations. Our end goal for this project will be to make a 3D rendering engine that looks something like this. So you can move around. We will have an object file and a texture, and the 3D rendering engine will take these two files and render our scene like this. So last time we created this bit of code which takes our object and texture file and imports it into our program as a mesh. In this episode we will be applying camera and object transformations. So we're going to write underneath project points vector 3 apply transformations. Then we're going to write vector 3 vertex, vector 3 location, and vector 3 rotation. And so in this code we will take our triangle's vertex and then its whole object's location and rotation over here, and then apply its transformations. Now for the camera, well, the camera is actually always in the same place, 0, 0, 0. What we're actually doing is when we want to move the camera right, we move the whole world in the opposite direction, so left. So that's actually how camera rotation and location works. We'll just move everything in the opposite direction. But for now, we will write this apply transformations code. So we will be starting off with y-axis rotations. So we'll write here float x1 equals bracket float vertex dot x times math dot cosine rotation dot y plus vertex dot z times math dot sine rotation dot y. Now the second line will be very similar, so we'll copy this and we'll paste it down here, but we'll change this x to a z, put a negative in front of this vertex x, and change the cosine to a sine and the sine to a cosine on this line. And that's it for y-axis rotation. Next we'll do x-axis rotation. Now the second piece of code is very similar to the first, so we'll just duplicate that, change this to y1 and z2, and here we'll change this x to a y, this y to an x, this vertex.z to z1, and this rotation.y to an x. We'll also change this addition to subtraction. On the second line we'll remove this negative, change this to z1, and this last one to x. And that's it for x-axis rotation. We'll now do z-axis. Now for this last piece of code, we'll duplicate the one above it again and change it to x2, y2, and then we'll change this to x1, this to y1, this to x2 and this to y1. Inside here we'll change all of these rotation to Z, and that's it for Z rotation. So we're rotating along the y-axis, then the x-axis, then the z-axis. Now here we'll write return new vector 3, and then we'll write x2 plus location dot x, y2 plus location dot y, and z2 plus location dot z. And that's it. So what we're doing is we're taking our vertex and we are applying its rotation, and then we are applying its location, and we're returning that. So down here in our paint, in our loop, we will apply our vertex's transformations, and then the camera, and then we'll project it. So here we'll write vector 3 v1a equals apply transformations triangle dot item 1 comma mesh dot location comma mesh dot rotation. We're going to copy this line and duplicate it 2 more times, change it to v2a and v3a, then item 1, item 2, and item 3. And so this piece of code here actually applies the object's transformations using our code up here. And then next we'll be doing the camera. So we'll duplicate this, change all of the A's to B's, and then inside here we're going to replace triangle item 1 with v1a, the next one with v2a, and then v3a. Now for the location rotation, we're actually going to go to the top and create a new vector 3 called camera location equals new vector 3, and then we'll do vector 3 camera rotation equals new vector 3. We'll also make this one here public so that we can access it later from a different script. And the inside here we can just write 0, 0, 0, and 0, 0, 0. Now back here we can replace mesh.location with camera location, and we'll do camera rotation, and we'll do the same for the other lines. And then we'll simply take this and put it into here. So v1b, project that, v2b, and v3b. So what we're doing is we're first applying the object's transformations and then the camera. Now the camera actually has to be in the opposite direction, so we'll put a negative sign in front of each one of these. And this will just reverse the direction, because remember, if the camera moves up, the world has to move down. So we will leave these values at 0 and we'll give it a try. And you can see that the car is still being rendered, so that's good. And now let's move the camera up by 1. So we'll replace this with a 1 and run it again. and you can see that our camera has moved up. We can do 2 and try that. Now the car's down there. We can even rotate it. So I'll change this to 0.5f and give it a run. And you can see that we're now looking down at the car. So if I increase this to 0.8, F stands for float, by the way, you can now see the whole car again. So we've added camera movement, camera location, rotation, and object location and rotation. So next time we will probably be moving on to texturing and then optimizing. So see you in the next episode.